So we're going to look at a couple of these problems. We're using the method of annihilator. And so the first thing that you do is you take the familiar part, the YC, and you're going to get m cubed minus 3m squared plus 3m minus 1 equals 0. I think I do remember this part. And then what happens is that you're trying to, knowing these are coefficients, constant coefficients, we don't have any variables in here yet. Variables on the right side of the equation, we got them, but not on the left side. Then what we'll do is we'll factor this. We notice so you can take out a 1, so it's m minus 1. And then when we were done with that, let's do the one more time. We'll go 1, negative 3, 3, negative 1. And what will make this 0? M minus 1, what will make it 0? 1. So we put the root 1 there. Drop the 1, multiply by 1, add these up, multiply, add these up, multiply, add these up, and you get a 0. That means you get it factors out. Okay, so now your answer is m minus 1 times m squared minus 2m plus 1 equals 0. And that factors into, of course, m minus 1 times n minus 1, which will be m minus 1 to the third. Everything good so far? Remember that? This is the same as d minus 1 cubed for our annihilator. Okay? So now we go to this part. This is kind of my part 2, this e to the x. Now for e to the x, we still have the d minus 1 cubed here. Now for e to the x, that's going to be d minus what? What's the power of x? The power of e is 1x, so this is d minus 1 again. Okay? And how many times would we take the derivative of both sides to get this to 0? 2. It would only take 1 to get 16 to 0, but it takes 2 to get negative x to negative 1 and then to 0. So you're going to have a d squared in there. That's all that means. This one d to the 4th? This one? Oh, you mean d minus 1 to the 4th?
No, because it has from 0 to the x.
Well, but you're going to have e to the x's in here, too. So that's this is where the redundancy, you don't have to guess. You can see that this is to the 4th. Okay? So here we had, when you did this to the 3rd, you had yc equal to c1 e to the x, right? But you're going to have another one. So how do we handle this? If this is cubed, we're going to have a c1, then what? X e to the x. That'll take care of the fact that this is duplicated. Since it's to the 3rd, you're going to do, this would be c2. Then you're going to have c3 x squared e to the x. Do you agree with that? Okay, so what we're going to add to this, they did it this way. I'm not sure I'm a fan, but they took the yc plus the yp together. They did c1 e to the x plus c2 x e to the x plus c3 x squared e to the x. And then they're going to put in, you're going to have with this one, since it's to the 4th, you're going to have a c4 x cubed e to the x. With the d, you're going to d squared, you're going to have c1, c5, and what else are you going to have since it's d squared? One more. C6x. Because two derivatives will take this to 0. It'll also take that to 0.
You show how the d minus 1 stuff, where those come from again? The annihilator above.
You got it. One more time. So you're okay with this part, Cam?
Yeah.
So we got that, and so that gives me the C1, e to the x, x e to the x, x squared e to the x. You're good with that.
Okay.
Then on this one, what happens is the e to the x is the annihilator is the derivative minus the constant in front of x, d minus 1. And then to get rid of x, we could take the derivative of both sides twice and get that to disappear.
That's gone.
Now it's gone.
So the second part.
So then the d minus 1 cubed comes from the left side? Or
The right, yeah, left side, correct.
d minus 1 cubed on the right comes from the minus 1 cubed?
Yeah, I'm putting them all together here so that we can see what we're dealing with the final y. Now, notice that I have this part here. We're not going to be dealing with as far as the finding the constants. We would need 3 givens points to find these 3 points. But this information we can find, and we're going to call it yp. I don't know, it doesn't matter which way you do it.
The c4 with x cubed e to the x comes from...
The fact that we have an extra fourth here. And then this is going to be a plus bx plus cx cubed e to the x. Are we having fun yet, Ethan?
Oh, yeah.
This is great stuff. Now, to your joy, I'm not going to finish this one. I think this is the part I needed to clarify, is how you get to this. The rest of this you can do, we did last chapter. But I just wanted to remind you that this part here is all YC. This part here. This part here is all YP. Together, they add up to give you the Y. And so what you're going to do is you're going to take the derivative of this, the second derivative of this, and then you're going to put that into the original equation, and then you're going to ascertain what A, B, and C are. And you're okay with that? Is everybody okay with that? Okay. Let's do 30. And 30 isn't one of the set ones, so that's good, because then you're going to get as far as you can. Y, and this is a little faster. I like to write the fourth derivative with 4 slashes. I'm not a big fan of putting a 4 there. It looks too weird to me. And then it's going to be minus 4y double prime is equal to 5x squared minus e to the 2x. Here's what I want you to do. I want you to get all the way down to, I want YC, I want YP, and I want you to get the Y with the constants. So let's take a peek at this one. For those gone, those that are watching this on the computer, m to the 4th minus 4m squared equals 0. You take out an m squared and you end up with m squared minus 4. Now this gives you m squared, m plus 2, m minus 2 equals 0. So we can convert that into a YC, which is going to be, and I never know which order to do this in. I'm going to do this in the order of the m squared first. So you're going to have C1 plus C2x. Do I do C3x squared?
Great question.
No, because it only takes, wait a minute, 3, no. Yeah, this is two derivatives, so yeah, 2 derivatives takes it out. Then it'll be C3 e to the, they usually do the positive first, and then they do the negative. Okay? So then, we took care of that part. Hang on to it, put it on hooks, save it for later. Okay? And then we're going to take a peek at this part. Okay, how many derivatives will it take for this 5x squared to go to 0? How many derivatives? 3. So you're going to have d3, and then we're also going to have, forget about this coefficient -1, just the coefficient of x here is 2, so this is going to be d what 2? -2. Now remember, we still had d squared, and we still had d plus 2 and d minus 2. Okay, we have all of those together. So when I put those into 1, you're going to get d to the, yes, I've said it, d to the 5th, d minus 2 squared times d plus 2. What that's going to do, I didn't want to have to write it again, but I will. So what that's going to do for my y is I still have c1 plus c2x plus c3 e to the 2x plus c4 e to the negative 2x. But we're going to, it took two derivatives to bring this down. We're to the 5th now. You're going to have to add a c5. I'm going to use a different color here. c5 x squared. What else do we need to add? c6 what? X cubed. What else do we have to add? Because we're to this. d to the 5th. We have to have a c7 x to the 4th. Because we're all the way to the 5th now. d minus 2 squared. Now d minus 2 squared, I had a d minus 1, so I need a c8 x e to the 2x. Do I need a c9 x e to the negative 2x? Nope, because that's still to the first power. This is my yp. Yp is going to be ax squared plus bx cubed plus cx to the 4th plus dx e to the 2x. That's my yp. And that's right. Then you do yp prime, yp double prime. You'll have 4 variables to figure out. That's all. And that is setting up all the way to yp. You can finish that by doing the 2 derivatives, plugging those back into the original up here, and then pairing off the x squareds, the zeros, the x to e to the 2x, and because, are you worried you have 4 variables here that you only have 2 terms here that you're not going to have enough? Well, you have those zeros, remember? Some of those are equal to 0, so that works out.